ASML's global monopoly and the rise of Huawei's EUV breakthrough. ASML, a Dutch technology powerhouse, holds an unparalleled monopoly in the production of EUV extreme ultraviolet lithography machines. These machines represent the pinnacle of technological innovation, enabling the production of the world's most advanced microchips, used in everything from smartphones to data centers. The equipment ASML produces is considered some of the most complex machinery ever created, reflecting decades of cutting-edge research and engineering expertise. For years, ASML has been the sole supplier of these machines to leading semiconductor giants like Intel, Samsung, and TSMC, giving the company an unshakable dominance in the global market. However, the tech industry was recently stunned when Huawei, one of China's most innovative technology companies, announced a groundbreaking patent for its own advanced EUV lithography technology. This patent has the potential to not only challenge ASML's global monopoly but also position China as a dominant force in the semiconductor industry. The emergence of Huawei's self-developed EUV machines could mark a turning point in the ongoing competition for technological supremacy. For decades, ASML's EUV machines were regarded as unmatched due to their complexity and precision. Yet now, Huawei's move signals a growing determination to break technological barriers and reduce reliance on foreign semiconductor tools. Is this the beginning of a new era in the global semiconductor market? Will ASML's dominance begin to waver as Huawei and other Chinese companies challenge its stronghold? These machines represent the pinnacle of technological innovation, enabling the production of the world's most advanced microchips, used in everything from smartphones to data centers. The equipment ASML produces is considered some of the most complex machinery ever created, reflecting decades of cutting-edge research and engineering expertise. For years, ASML has been the sole supplier of these machines to leading semiconductor giants like Intel, Samsung, and TSMC, giving the company an unshakable dominance in the global market. The company's EUV lithography machines are key to producing high-performance microchips, smaller than 10 nanometers. These chips power modern devices such as iPhones, advanced computers, self-driving cars, and vast data centers that run the cloud infrastructure of the digital world. What makes ASML's machines so revolutionary is their ability to print intricate patterns at an atomic level of precision. These patterns form the microscopic circuits that make up today's semiconductors. Each EUV machine is roughly the size of a city bus and comes with a staggering price tag of up to $200 million. Producing these machines is no small feat. ASML spent over a decade developing EUV technology in collaboration with major industry players like Intel and TSMC. These machines rely on extremely short wavelengths of light, specifically 13.5 nanometers, to create patterns so small they cannot be achieved using traditional methods. To put this into perspective, a single human hair is about 80,000 nanometers thick, highlighting the sheer scale of precision involved in EUV lithography. At the heart of an EUV machine is its light source, which generates tin plasma using high-energy lasers. This tin plasma emits light at a 13.5 nanometers wavelength, which is then reflected and manipulated through a complex system of mirrors and lenses. The light carries circuit patterns onto a silicon wafer coated with a photosensitive material called photoresist. Given the complexity of these machines, ASML has maintained a near-total monopoly on EUV lithography for years. No other company has successfully matched ASML's capabilities until now. Huawei's bold breakthrough, a game-changing patent. Huawei's recent announcement of its EUV lithography machine patent shocked the global tech community. Huawei's patent includes critical components necessary for producing advanced chips, such as a 13.5 nanometers EUV light source. To understand the scale of this potential shift, let's explore the fascinating story of EUV lithography machines. The significance of Huawei's breakthrough. and how this development could reshape the future of chip manufacturing. ASML, the backbone of modern microchips. ASML has been at the forefront of semiconductor manufacturing for decades, solidifying its role as a critical supplier to the world's biggest tech companies. However, creating EUV lithography machines is an incredibly challenging process. ASML's machines alone involve thousands of specialized components, many of which are sourced globally. The engineering and precision required to develop these machines took ASML over a decade, supported by vast resources and collaboration with top industry players. Huawei's breakthrough signals its determination to innovate and challenge ASML's dominance head-on. The significance of this achievement cannot be overstated, particularly as it comes at a time when the United States has imposed restrictions on China's access to foreign semiconductor equipment. The U.S. government has pressured companies like ASML to hold sales of EUV machines to Chinese firms. Citing national security concerns, this move effectively cut off China's ability to access the critical tools needed to produce cutting-edge chips. Yet, Huawei's innovation shows that China is making strides toward self-reliance in semiconductor technology. If Huawei can successfully commercialize its EUV lithography machines, it could reduce China's dependence on foreign technology and bolster the nation's domestic chip production capabilities. Why EUV technology matters: the future of semiconductors. To understand the impact of Huawei's breakthrough, we need to grasp why EUV lithography is such a game-changing technology. Traditional lithography methods, which use longer wavelengths of light, are reaching their physical limits as microchips become increasingly smaller and more powerful. Manufacturers require tools capable of printing ultrafine patterns at an atomic scale. EUV lithography solves this problem by using shorter wavelengths of light at 13.5 nanometers. EUV light enables chipmakers to produce transistors and circuits at single-digit nanometer scales. This allows for higher performance. Smaller transistors mean faster, more powerful processors. Energy efficiency: chips consume less power, enabling longer battery life in devices. Greater density: more transistors can be packed onto a single chip, enhancing computing capabilities for decades. ASML has been the only company able to deliver this technology. EUV machines involve some of the most precise engineering in the world. From high-energy lasers to reflective mirror systems made of specialized materials, the entire lithography process occurs in a vacuum environment to prevent contamination, as even the smallest particle can disrupt the printing process. Huawei's entry into this market is not only groundbreaking, but also strategic. The company has long faced challenges due to U.S. trade restrictions, which cut off access to critical tools and technologies. By developing its own EUV lithography machines, Huawei is taking a significant step toward overcoming these restrictions and achieving technological independence. The geopolitical impact: China's race for semiconductor self-sufficiency. Huawei's innovation comes at a time when the global semiconductor industry has become a key battleground in the geopolitical rivalry between the United States and China. Semiconductors are the backbone of modern technology, and the ability to produce advanced chips is critical for economic and national security. The U.S. government has taken aggressive steps to limit China's access to cutting-edge semiconductor tools, including EUV lithography machines. ASML, as a European company, has also faced pressure from the U.S. to restrict sales to Chinese firms. These restrictions have posed significant challenges for Chinese manufacturers who rely on foreign equipment to produce advanced chips. However, Huawei's breakthrough represents a major victory for China's push for semiconductor self-sufficiency. The Chinese government has prioritized investments in chip manufacturing, pouring billions of dollars into research, development, and domestic production capabilities. Huawei, with strong support from Beijing, has emerged as a leader in this effort. Beyond EUV technology, Huawei is also investing heavily in other areas of the semiconductor supply chain. The company's Hubble Technology Investment Fund has supported innovations in chip design, materials, and manufacturing processes. Huawei's recent success with its Kirin 90 OOS processor, produced using SMIC's 7nm process, demonstrates China's growing capabilities in chip manufacturing despite U.S. sanctions. Other Chinese tech giants, including Alibaba and Tencent, are also entering the semiconductor space. These companies are exploring RISC-V architectures, an open-source alternative to Western chip designs. By adopting RISC-V, China hopes to reduce its dependence on foreign technologies and build a more resilient semiconductor ecosystem. Can Huawei compete with ASML? While Huawei's patent is a major milestone, the road ahead remains challenging. Building and commercializing EUV lithography machines requires overcoming significant technological hurdles. ASML's success is built on decades of research, collaboration with global industry leaders, and access to specialized components from around the world. Huawei will need to replicate this success under very different circumstances. Developing EUV machines requires vast financial investments, specialized expertise, and access to advanced materials and tools. Moreover, ASML's machines are backed by a global supply chain involving hundreds of suppliers, making them difficult to replicate. Despite these challenges, Huawei cannot be underestimated.